Welcome to all the students, and in this lesson we'll be continuing with November 2023 paper 1, question 3 and 4. Let's get started. So question 3, given the geometric series, so remember geometric, constant ratio, 3 plus 6 plus 12 to the n terms. Write down the general term of this series. So we know when we refer to a geometric series, the general format would be Tn is equal to a times r to the power of n minus 1. So I do know that a is equal to 3. Then every time we are multiplying with 2. So it's times 2 to the power of n minus 1. And that's your general term. The next question, however, is a sigma question. So please remember, sigma is referring to Sn, right? Sigma means the sum of. It's referring to an Sn type of question. So let's quickly have a quick look. So we have a sigma from p equal to 1 to k, where 3 over 2 to the power of p is equal to 98,301. So first things first, we need to get the value of k. Right, so let's start working this out. So I know if I have a sigma of p equal to 1k, 3 over 2 then times 2 to the power of p equal to the 98,301. I immediately can start with the Sn. And now I need to double check. The first term, if I substitute in a 1 here, would be 3. If I substitute a 2 in, I will get 6. And a 3 in, I would get 12. So I can see it's exactly the same one as previously, where your a is equal to 3 and your r is equal to 2. So Sn is equal to a r to the power of n minus 1 over r minus 1. Let's substitute in. So a, I do know, would be equal to 3. 2 to the power of n minus 1 over 2 minus 1. This is all equal to 98,301. So just hold on. I would rather rewrite this and not use n, but say k, because I know we actually added everything up to k, or a k number of terms. And now I need to solve. So if I start to simplify, so first of all, I will just divide by this 3 both sides. I will get that. And let's quickly have a look. So the best way would then be to say 2 to the power of k minus 1 is equal to 32,767. Take the 1 over, so 2k is equal to 32,768. So what exactly is the plan? 2 options. We can either go for prime base, which would have been my first option. Therefore, k is equal to 15, or you could have immediately used your logs and just said that it means k is equal to log, remember 2 would be now your base, of 32,768. And you would also get 15. Final answer. Right, let's quickly do the next question. 3.2, a geometric sequence and arithmetic sequence have the same first term. So both have a that's the same. Common ratio of geometric is a third. Common difference of arithmetic is 3. The sum of 22 terms of arithmetic is 734 more than the sum to infinity of the geometric. Calculate a. So very important, we do have r and we do have d. A is the actual question about. The whole equation will be based on this last sentence. So if I were to compare arithmetic to geometric. So let's do it like this first. I would say the sum of the first 22 terms equal to sum to infinity. But look at the question. The sum of the 22 terms of the arithmetic sequence is 734 more than the infinity of the geometric sequence. Meaning, we will now have to specifically say plus 734. Now, please read carefully, because if I say 5, the number 5, is 3 more than 2, you would say 5 is equal to 2 plus 3. So the 3 goes with the one that's less. So remember that. So now I can just substitute in. So I would typically go and just say 22 over 2. We're going to use quickly the equation. 2 times a, which we don't have, plus 22 minus 1, and your common difference is 3, equal to, sum to infinity, it's again a, over. Then we have 1 minus a third, plus 734. Now I need to simplify a bit. So if I were to multiply on the left-hand side and simplify as far as possible, we would end with 22a plus 693 equal to, and on this side I would actually get 3a over 2 plus 734. Now I need to solve for a. So I'll typically take everything to the one side, multiply out with a 2 definitely. So that should maybe be the first option first. I need to get rid of this 2. 44a plus 1386 is equal to 3a plus 1468. So if I take all the a's over and all the normal values to the other side, we'll get 41a is equal to 82. Divide by the 41 both sides, and you will get a is equal to 2. And that would be your final answer. Let's get to question 4. So now we're starting with functions and graphs. So sketched below is a graph of f is x is equal to 2 to the power of x minus 4 with this limitation. Very important. So it starts at negative 2 included and ends at 4 not included. A and B are respectively the y and x intercepts of f. So let's just quickly talk about this graph in general. That negative 4 is indicating that the graph moved 4 units down. So I already know the asymptote should be at y equal to negative 4. I also know normally exponential would have to have a y-intercept at 1. But if I moved everything 4 units down, it will now be at negative 3. Right, let's look at the first question then. Write down the equation of the asymptote. That's simply y equal to negative 4. Next question. Determine the coordinates of B. Now B, if you look closely, is the x-intercept. So what do we know about an x-intercept? We know that y is equal to 0. So x-intercept, y is equal to 0, which means y is equal to 2 to the power of x minus 4. So 0 is equal to 2 to the power of x minus 4. Now I just need to solve. So I will have 2 to the power of x negative is equal to negative 4. 2 to the x is equal to 2 to the power of 2. Therefore, x is equal to 2. So the coordinate of B is 2 and 0. Quickly look at the sketch. Are we comfortable with that value? Yes, I am, because it's on the positive side and it's definitely lower than 4. So that is definitely a 2. And I'm happy with that, comfortable with that answer. Done and dusted. Right. Now, let's quickly have a look. Sorry, let's go back there. 2 and 0. Remember to give it in coordinate format. Now they say determine the equation of k, a straight line passing through A and B. A straight line. We know a straight line is y is equal to mx plus c, and we do have the coordinates for A, which is 0 and -3, and B we have now as 2 and 0. Let's get the equation. So m is equal to y2 minus y1 over x2 minus x1. So I'll have -3 minus 0 and 0 minus 2. So m would be equal to -3 over -2, which is just 3 over 2. Now, very important, I can say y is equal to 3 over 2x plus c. But what do we know about c? That's the y-intercept. Your coordinate A is the y-intercept. And there's the answer. As simple as that. Let's quickly do the next question and continue with question 4. Calculate the vertical distance between K and F if X is equal to 1. So let's quickly go back to that sketch real quick. Let's go for a smaller version of it. So I know I've got a straight line here, more or less, and that's your K. So if I compare and I look at the vertical distance at x equal 1, which is more or less there, it's the y value of f minus the y value of k minus the y value of f. So the distance would be the y value of k minus the y value of f. And I first need to get those two values. So once again, they said it's at x equal to 1. So what do I need to do? Physically need to get the corresponding y values. So I'd first go and calculate f in the point 1 and k in the point 1. So let's quickly give it a go. So 2 to the power of 1 minus 4 is equal to -2. 3 over 2 times 1 minus 3 is equal to -3 over 2. So we can continue here at the top and say this means it's -3 over 2 minus -2. Careful for your signs, it needs to be a positive value as it is a length. And we will get half units. So remember, it is half units, it's a length. So it's the y value at the top minus the y value at the bottom. So it's very important to have an idea which one of these two functions are above the other before I get the length. Right, let's go back. Next question. Write down the equation for g. If it's given that gx is fx plus 4, what does that plus 4 mean? It means the whole function is moved 4 units up. Right, so I do know that fx is equal to 2 to the power of x minus 4, which then means that gx is equal to 2 to the power of x minus 4 plus 4. So it's simply 2 to the power of x. And that would be 4.5. Let's quickly check. Next question. 4.6. Write down the domain of the inverse. And the next question is actually to get the equation of the inverse. So domain, let's quickly have a go at that. Right, again, let's just quickly look at this graph. So remember with inverse, your domain and range swaps around. So if I were to sketch this, so remember, we would have a function from here here and it goes up to there if it's just 2 to the power of x. Right. Now, very, very important. We need to get these two coordinates. So if, let's quickly get that first. So f in the point of -2 is 2 to the power of -2 minus 4, which is 1/4 minus 4. And you would simply get, it's just 2 to the power of -2. Remember, we're not moving it up or down anymore. This is the normal one, so it's just 1/4. If I look at the last coordinate I need to get here, it would be 2 to the power of 4, which is equal to 16. Therefore, I can simply just say the following, that the range for the normal function would be from 1/4 to 16. Range. We know if we do the inverse, it's going to be the opposite. This range will become actually its domain. So let's quickly jot that down. So for the domain, I will simply say x is an element of 1/4 to 16. And remember, the 16 is not included because of the specifications they gave us where 4 is not included. So x is an element of real numbers. Now, last question. Write down the equation of g -1 in the form of y is equal. Now remember, if we look at the inverse, we know gx is equal to 2 to the power of x, meaning g to the -1x, the inverse is the log, and this value, the base of the exponential equation, will be the base of the log in the inverse, 2x, and that's your equation. So just answer it as y, because they specifically asked for y equal to some expression, and that would be the answer. And that's all for this lesson. I'll see you definitely in the next one.